All right, you guys, welcome back. It's good to have you here. We're heading into Unit 10, which is a discussion about circles. All right. You guys can use anything to draw the circles. Don't be afraid to hand draw your circles, even though they may look like some sort of beaten up orange that's been thrown down the hall. I used a basic compass to draw this one just to make it look nice and pretty. But you can grab pretty much anything, your favorite water bottle, the cap to your water bottle, anything that's circular if you want to draw something that's nice and pretty. But let's look at some of the stuff that is going on in a circle.
Nice TV.
Thank you.
Happy day.
You too. Sorry, that was Miss Swan just coming to join us. So you guys, circle. The point here in the middle of this circle is referred to as the center. All right. If we added a letter there, then we would describe this circle. And maybe I should just go ahead and do that. Let's just call that point A. Then we might name the circle. Circle A, or you might just see a simple symbol of a circle like this. Okay, so one of the things that you might already know the answer to, if I had a segment whose endpoints were the center of the circle and somewhere on the curvature of the circle, all right? And I'm not going to write out these definitions, but again, I will feel free to pause this video, rewind. I'll try and speak very clearly. Again, a segment whose endpoints are the center and somewhere on the curvature of the circle is called a radius. All right. If I had a segment whose endpoints are both on the curvature of the circle, this is called a chord, C-H-O-R-D. Again, a segment whose endpoints are on the curvature of the circle. Now, should that chord, if we start moving these endpoints down, that segment will get longer and longer and longer until we pass that center point, and then it'll get shorter, shorter, shorter. But if it's going straight through the center of the circle, it's still a chord, but it becomes a bit more special now. This is called a diameter. And there's an infinite number of diameters, an infinite number of chords, an infinite number of radii that can exist in a circle. All right, let's keep going here. Let's say I took this chord and I extended it some. So a chord and then some. So sometimes this could be a segment or a line. A chord has to be a segment. If we have a line that contains a chord inside of it, that's called a secant. A secant is going to have two intersection points on the curvature of the circle. It's going to have that chord somewhere inside of it. Now realize if I start pushing this secant up, those intersection points are going to become closer, closer, closer until eventually it's possible for this line to intersect the circle only at one point. So if it's a line that intersects our circle only at one point, then it's called a tangent. You will certainly need to know the definitions of these terms. Some of them are going to be new to you. Please realize that radii, diameters, all these things can create intersections and angles inside of these objects, which is very important. So again, let's continue talking about these basics. I drew 2 more circles, one of which just not dark enough. So I'm gonna, this is not easy, but if we, let's just hand draw, make this a little bit darker. Hey, that's not bad, but I'm tracing, so, I'm cheating just a little bit, all right? So other ways to discuss circles. We can divvy this circle up. Let's say I put a single point here on the circle, and I put another point here. We can break these circles up into pieces of the curvature, right, which are called arcs. This is an arc, A-R-C. So the name of this arc, the way we would name it, we would put the 2 end points, and it's not a segment, so we're not going to put a segment above it. We're going to give it an eyebrow. We're going to give it an arc above it. That would be arc AB. If I put another point here, we have other arcs. Now we have arc BC or CB, it doesn't matter. And we have this arc here, maybe I'll call that arc CA. All right. Now these arcs, all right, these arcs are measured in degrees. Measured in degrees. Very important. All right, so you can see that this arc, certainly not half of the circle, it's less than half of the circle, but if I took arc AB, if I added it to arc BC, and then I added arc CA, those 3 arcs would total the entire circle. Well, if we're talking about degrees and we're going 1 trip around in a circle, that's going to be 360 degrees. All right. These arcs here, like arc AB, if it's less than half of the circle, we call that a minor arc. Less than half of the circle. And so maybe you understand if we're talking about more than half of the circle, that's going to be called let's use a different color here. It's called blue. That's what we're going to call a major arc. More than half. Of a circle. So you got to start to think, if we want to talk about a major arc, so arc AB, the rest of the circle, if we started at A, went all the way around here, but understand, we can't call that arc AB. If we say arc AB, everybody's going to think we're talking about this small one. So if you want to talk about a major arc, an example would be arc ACB. So we use a third letter to describe to everybody that we're heading around the circle the other way. Okay? So we have minor arcs, we have major arcs, and they're all measured in degrees. Okay? And one other thing that we can do is if I were to bring in my center point, let's call that, my center is P, I can create angles. So if I made an angle here using a radius from P to A and a radius from P to B, I now have an angle here. If we are forming angles using the center of the circle, this is cleverly named a central angle. Okay? And so if I knew the measure of this arc, let's say that the measure of arc AB, I don't know, that looks like about 100 degrees. Well, the measure of this arc will always equal the measure of the central angle. So the measure of angle APB would also be 100 degrees. So maybe we want to write that down. Arcs are measured in degrees, and they will equal the measure of their central angle. So if I drew another radius, if I knew that this central angle was 100 and let's say 95 degrees, then I know that arc AC is also 95 degrees. And since I know two of these angles is 195, I've only got so much left for the 360 degrees. So if I took a 360 degrees and I got rid of the 195 that I know about, then I would know I've got 165 degrees left. And I did that in my head, so I hope my math is correct. That means this has got to be 165 degrees, and this is also 165 degrees. Central angles will equal the measure of the arc inside them. Okay? And just to add on to that, all right, let's again, so if I got another circle here, let's say I had some arc here, FG. If I knew the measure of that was 60 degrees, if I drew a central angle, I know it would be also 60 degrees. If I pull that vertex back and put it on the curvature, tough to draw, this is called an inscribed angle. An inscribed angle is going to equal half of the measure of its arc. So, and maybe you can see that the central angle here is bigger than if I pull the vertex back than its inscribed angle. So this would be 60 degrees. The inscribed angle would be 30.
I'm totally not out there yet. It's cold. Don't stand at that door.
Cool.
Yeah.
All right, you guys. So this can be pretty interesting and difficult because the tough thing to think about, if I move this vertex point, I create an inscribed angle over here, it's not going to change. It's still going to be half of this arc that is inside of it. Okay? So try and remember the big things that we covered today. Inscribed angles will equal half of their arc. We've got these arcs here. We've got central angles that equal their arc, and make sure we also are aware of these basic items here. We got to be able to discuss tangents, chord, secants, diameters, radii. We got to be able to name them. So to understand if this is a chord, if I ask you to find a chord on the test, if this is W and X, I say, find me a chord, then you would say, oh, I found one. That would be segment WX. Okay, make sure we're naming things just like we did on day one of this course. All right, so hopefully that makes sense. Again, use these videos to study. And if you do that ahead of class, then we can apply some of these ideas and explore them further in class. I look forward to seeing you.